Okay, so here we have a cube and the octahedron. And do you remember how the cube and the octahedron were related to each other?
Well, we could match up the symmetries, like the rotations, we could match them up.
How?
Well, I think for the octahedron you can rotate the triangles up and over. Like for the rotations.
Tell me what you mean.
Like for these rotations on the cube.
Okay, what matches in the octahedron? Okay, let me show you another rotation of the octahedron that matches that exactly. If I stand it up on its edge like this, do you see this square?
Yeah.
See that rotation?
Yeah, and that's the same as rotating.
Okay, now, when I rotate this way, what am I rotating about in the octahedron?
You're rotating about these top and bottom points.
What are those called?
The vertices.
Vertices. When I rotate the cube, what am I rotating about?
You're rotating about...
Well, about the center, or about this top face and the bottom face.
Okay, so the vertices correspond to the faces. Can you see? Which face of the cube does this vertex correspond to? This one here.
Well, but on this one there's actually middle, but there's no middle vertices here.
Right. It corresponds to a face. Which face
Looks
does
like it corresponds to that.
corresponds to that face? How about this one here?
It corresponds to that one.
Yeah. So do you see how the vertices correspond to the faces?
Yeah.
Okay. So I can make an octahedron by taking the middle of every face and connecting them in a cube.
Wow.
It's a very interesting relationship that we'll study many years from now. These are called duals of each other. All right, now let's look at an icosahedron and a dodecahedron.
So you can make an icosahedron out of a dodecahedron.
Well, let's see. There was fivefold symmetry when I rotated around when I rotated the icosahedron around opposite vertices,
Well,
right?
this one would correspond to up here, and that there is a fivefold symmetry.
Okay, what's the fivefold symmetry in the dodecahedron?
It's rotating
Around what?
around the top and bottom.
Okay, so rotating around the faces, right?
Yeah.
Okay, so does this vertex correspond to a face?
That goes to the top face.
Top face. How about this one over here? What
Corresponds
face?
to this one.
Do you see it?
Yeah.
So do you see,
Yeah.
if I connected up the centers of the dodecahedron, what would I make?
An icosahedron.
An icosahedron. Isn't that cool?
Yeah.
Yeah, it's pretty amazing. They are also duals of each other.
What would you make if you connected up the centers of an icosahedron?
Very good question. See if you can see. If I connected up those centers, just however you want to, why don't you guys talk about it? That's a great question.
Well, the centers, you would make a pentagon here,
Okay.
and I think it would turn into this.
Whoa.
Whoa! Wait a minute. What?
So dodecahedron can turn into an icosahedron, and icosahedron can turn into a dodecahedron.
Isn't that amazing?
Yeah.
Isn't three-dimensional geometry cool?
Yeah.
All right. Good job, guys. Good job.